Hi, this is Vijita. Today we'll learn about the types of unsupervised learning with examples and algorithms also. Already in the previous session, we learned what is machine learning and how many types of machine learnings and what are the types of supervised learning with what are the types of supervised learning with examples and algorithms also. And now we discussed about the types of unsupervised learning. In the previous session, Introduction to Machine Learning, we discussed about the supervised, unsupervised, and reinforcement learning. Unsupervised learning means type of machine learning where the model learns from the unlabeled data. Machine learning, supervised learning means labeled data can be predicted the targeted variable. In the unsupervised learning, it is the model learns from the unlabeled data. In the image, the raw data is input raw data is onions, brinjal, capsicum, and apple. Now it is a unlabeled data. Now we will the output of the predicted, that is identifying the how to identify the images to unsupervised learning. That means it is identifying patterns and structures within the data without predefined categories. We can't be categorized. In the supervised learning, we can be categorized, but in the unsupervised learning, we can't be predefined categorized. The common applications include using the unsupervised learning as the clustering. So in the example, having the unlabeled data can be interpreted to machine learning algorithms that the processing will be output as the predicted images. It can be based on the size, shape, color. So the predicted output will be there. Next one, types of unsupervised learning. The unsupervised learning has the machine learning has the three types. There are clustering, association rules, and dimensionality reduction. Coming to clustering overview, it is a grouping the similar data points together in the process that helps in the discovering the inherent structures in datasets without any prior knowledge of the group of definitions. That means customer segmentation, examples of the clustering as the customer segmentation and image compression. In the common clustering algorithms are used in the unsupervised learning as the k-means clustering data. That means partitioning the data into k clusters. Large number of data set can be grouped data can be single data divided in the data sets. That is the k-means clustering. Hierarchical clustering means building a hierarchical structure or the tree-like structure. Density-based clustering means it is based on the density. Mean shift clustering is finding the clusters based on the mode seeking. Spectral clustering means it is using spectral graph theory for clustering. These are the clustering algorithms in the unsupervised learning. In the next further sessions, we discuss in the briefly what is the k-means clustering, hierarchical clustering, and how and density-based clustering, mean shift clustering, and spectral clustering, and how to implement the algorithms used in the different data sets. Coming to k-means clustering. K-means clustering is the one of the most popular clustering algorithms. It means data partitions data into k clusters. Already we discussed in the previous slide. We are the partitions data into k clusters. The algorithm iteratively assigns the data points to the nearest cluster centroid and updates the centroids. So in the given diagram, these are the different data sets in the clustering group. This clustering is reach to the one as the centroid point, then reaches the divides the data. In the after clustering, it is a centroid can be reached the maximum value, then the clustering will be k-means clustering will be reached there. Implementation of can be done using the libraries like we are using the libraries as the scikit-learn library in the Python with a few lines of the source code. So after we discussed the how implementing the libraries, where to using the libraries and how to import the data set, what is the data pre-processing, then we will discuss it. Coming to next one is hierarchical clustering. Hierarchical clustering, it's a create a like tree structure. That means structure of the nested clusters. It can be based on the agglomerative and divisive approaches. Agglomerative means bottom up approaches. The bottom up approaches means each cluster having the based on the different on the group of the clusters. So first step one is a cluster A is maximum pi into all the clusters to last cluster. And next step 2 is B C clusters has the same clusters maximum points, so it can be merged as that together as the BC. And in the same way D is also in the same merge points are the same, so it is a DE cluster and then F cluster. So in the step 2 it can be merged in the A, B, C, D, and F. The step 3 is combining the nearest values can be as the A, B, C, D, E, and F. These are the maximum. We find out the maximum clusters. Then it can be combined with the D, E, and F. After step 4, the D, E, F, and B, C, E are the same clusters maximum reaching point. So that's why we indicating that B, C, D, E, F. And last one, the A point and B, C, D, E, F are the reaches the cluster maximum point. So it can be combined the A, B, C, D, E, F. So it is a agglomerative clusters. So similarly, underlying hierarchy structures that can use the achieve that analyzing the data of the hierarchical. And divisive clustering means it starts from the one cluster to until it reaches the individual cluster of the data. That means a bottom up approach. That's a top down approach. That is A, B, C, D. Step 1 is the A, B, C, D, E, F. And it combines the B, C, D, E, F, and A is a clustering point in the reverse of the agglomerative clusters. This method is used for the creating a visual representation of the data through dendrograms. And next one is the another type of the unsupervised learning is association rule. Association rule is also known as the common technique used the discovering identity associations, the unsupervised learning. That is a rule based learning technique. So it is useful for the relations between the parameters of the large data set. That is basically used for the market basket analysis to helps to better understand the relationship between the different products. So coming to example, the in the example of the association rule, shopping stores using the algorithms based on the technique find out the relationship between the A and item A and B. So the one customer sell only milk and bread, and another customer sales bread, eggs, and butter. And another customer 3 can be expected based on the customer 1 and customer 2 using the association rule. That is useful for the relation between the based on the customers. The common algorithms in the association rule are the a priori algorithm. It is a classic method for the rule induction. And FP growth algorithms are the efficient alternative a priori. Eclat algorithm in the exploiting closed item sets for the efficient rule mining. And efficient tree based algorithms are the handling the large data set with the scalability. And next, dimensionality reduction. The third type is a dimensionality reduction. Dimensionality reduction means large number of data set having the number of attributes. It can be reduced using the reduce. For example, one small data set having the 10 sample data, but in the attributes are the 100 attributes. But it's very complicated for the find out the unsupervised learning, find out the predicted. That means it can be reduced. What are the necessary data will be available in the attributes? The unnecessary attributes will be removed using the dimensionality reduction. So it helps to simplify models, reduce noise, and improve the visualization of the data. The techniques used in the dimensionality reduction as the principal component analysis and distributed stochastic neighbor embedding. So the principal component analysis is the data into a new coordinate systems where the greatest variance lies on the first coordinate. So further sessions we discussed about in the session explain the principal component analysis. It reduces the dimensionality by selecting a subset of the principal component analysis. That it can be used importing the library as the scikit-learn. So anomaly detection overview. Anomaly detection overview means for the banks having the customer credit card deductions, bank credit card deductions using the anomaly detection. It items every that's different significantly from the majority of the data. The explore machine learning models can be explainability to identify the detection points with the previous data. For example, on customer transaction only 2 or 3 transactions in the every day, but one of the day he has transacted 4 or 5 transactions. We can identify using the anomaly detection. That means the hackers can detect the hackers can credit the money as the customer. It is crucial various applications including fraud detections and network security also. The unsupervised machine learnings are useful for the detection anomalies without the label data. So these are the main topics covered in the unsupervised learning. That means what we gain in the this session means what is meant by unsupervised learning, how many types of unsupervised learning, and the types of supervised learning has the clustering, association, and dimensionality reduction. Clustering means it can be similarity data points can be reached to the centroid. Association rule means for the find out the relation between the customer segmentation, and dimensionality reduction means identify reduce the attributes of the data set. These are the topics covered in this session of on types of unsupervised learning. Thank you.